This lesson is for FST Lesson 1-4 on Boxplots. A boxplot is a visual display of the five-number summary. Typically in class we will do a cube activity so that students learn how to do the five-number summary visually. So if students haven't done that yet, they should ask me in class and I can teach them that fairly quickly. So students learned from their cube activity that the five-number summary is the median, and then the minimum number, the maximum number, and then the other two pieces that we did in the cube activity was to find new items which the students probably haven't learned yet, and that's quartile 1 and quartile 2. When we divided up the cubes into quarters, we needed 3 dividers to do that, and those dividers are called quartiles. So you spell the word quart and then you say I-L-E after that. So it's quartile 1, and I'm sorry, here this should say quartile 3. Technically the median is considered quartile 2, but it is such an important idea of finding the middle of data that we typically don't call it quartile 2 any longer, we just simply call it the median. So quartile 1 is the median of the lower half, and quartile 3 is the median of the upper half. And quartile 3 is the median of the upper half. The minimum is always the lowest number of your data, and the maximum is always your highest number of the data. It is very important that students remember that when we worked with the cubes in our five-number summary activity, we found the median first. Then it was very easy to find the middle of the lower half and the middle of the upper half very easily. Most of the time people will have more difficulty finding data and putting it into quarters than it is to cut the data in half and then cut it in half again and again. Let's go ahead and try this now with some actual data. So if I work with the data here ranging from 29 to 50, they ask us to give the five-number summary. So I'd first want to know how much data I have so that I could find the middle. So I just count it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When there's 10 pieces of data, the middle two numbers will be in the middle, will represent the median. And so to actually find the value of the median, I would add those two middle numbers together and divide by 2. So if I add 40 and 43 together and divide by 2, I get a new value of 41.5. So now I have a lower half and an upper half of the data. The middle of the lower half is clearly going to be 37. The middle of the upper half is clearly going to be 46. So I have 3 of my pieces so far, and then the min and the max are easy to find, 29 and 50. So normally when you give the five-number summary, you would actually list those out. The minimum is 29 and so on. For time's sake, I'm not going to go ahead and write those out. One of the other things that you will do with the five-number summary is talk about, or maybe be asked to calculate, the interquartile range, the IQR. The interquartile range is simply found by taking the difference of the quartiles, quartile 3 minus quartile 1. Another piece that we can use with the five-number summary is to turn it into a visual display called a box plot. Sometimes the box plot is called a box and whisker plot. The parts of the whisker plot are the parts of the five-number summary. The bar that's on the far left is the minimum value. The bar on the far right is the maximum. And the whisker pieces show you how far apart the minimum is from quartile 1, and the maximum shows you how far spread out the maximum is from quartile 3. So the quartiles are the edges of the box portion of the box plot. There will be a line somewhere on the interior of the box, and that will be the median. It's important for students to understand that the median may not necessarily appear in the center of the box. It may not be in a symmetrical place. It is the middle of the data, but the box plot may not show it symmetrically. The benefit of the box plot is that it shows where the different quarters of the data are and how they are spread out. You can clearly see from the way that this box plot is laid out that there's not a very large span between quartile 1 and the median. That means the data that's there is clustered close together, whereas the data here is much more spread out. that might be something that might be curious for people to notice when they're working with data. It might be important to know that information. So that's the benefit of making a box plot. You can visually see the spread of the numbers. So we're going to go ahead and make a box plot real quickly for this provided data. A box plot always has a number line. Always give yourself enough room in case you need to modify your scale. The scale always needs to include numbers above and below the minimum. It does not always have to contain a 0 like students are used to in a regular number line. So I'm going to start at 30, and I know I need to go to about 85. So if I went by 5s for the grid marks, I'd probably have plenty of room here. But I'm only going to label every other. Again, make sure that your scales and your spacing are consistent. Make sure that you go above and below the minimum and maximum values. Then you're just going to make vertical bars that are parallel to each other and symmetrical and the same size for each of the 5 number summary values. Know that you're simply estimating where those are going to be located. And know that the heights of the bars is irrelevant as long as you're consistent. So we have our 5 number summary listed here. Now I just need to turn it into a box plot. Ignore the beginning and the end lines and just connect the middle 3 to turn it into a box. Then you connect the center point to the box to make your whiskers. So now you can see that a quarter of the data here is fairly closely chunked together, whereas from quartile 1 to the median there's a wider spread of numbers. So for example, if these were ages of people, it might be good to notice that the young 30-year-olds are very clustered together here as opposed to the wider spread here of the 40s, 50s, and 60-year-olds. Another important idea when you're working with box plots is to consider where the middle 50% of the data is going to be. Remember that this data is divided into quarters, and so everything below the median represents half or 50% of the data. Everything above the median is also representing 50% of the data. So the middle 50% of the data is going to be whatever's inside the box. So we're talking about 25% below the median and 25% above the median as representing the middle 50%. So the generic or general way of answering the question is the middle 50% is inside the box. It's also represented by the IQR or the range. More specifically in this question, we would say it's between 65 to 34. So know that when you're mathematically trying to give an answer, you would want to give the numerical portion of the data. Mentally, you'd be thinking, okay, I want to give the numbers inside the box. Another thing that we do with box plots and with data in general is we want to identify whether or not there are any outliers. An outlier is an extreme outcome. A piece of data or two that is extremely separated from the rest of the data and may skew how the data is calculated. So if we can identify an outlier, sometimes we can exclude it from the data and recalculate. Keep in mind that a lot of times people will talk about outliers just in their opinion, and they'll say, I believe that to be an outlier, whereas mathematically, as students and as studiers of math, we know that we need to verify that information mathematically. The book does not do a very good job of highlighting the formulas that students need for calculating outliers. They are simply embedded inside a random paragraph in the reading. So I want to make sure that students copy the formulas here very carefully. To identify outliers, you're actually going to do 2 calculations. The first calculation is quartile 3 plus 1.5 times Q3 minus Q1. And then the other calculation is Q1 minus 1.5 times Q3 minus Q1. So if you're going to talk about this portion here, the Q3 minus Q1 part, again, that is referred to as the IQR. So when the book asks you the question of trying to find an outlier, many times they'll say, use the 1.5 times IQR criterion to determine if there are outliers. So they're referencing the fact that you should do that calculation. So let's go ahead and do that calculation for the example here, and then we'll have students try it again with the previous example numbers. So you just need the numbers, and you just need to go ahead and calculate them. So Q3 here that's given is 100. We're going to add that to 1.5 times the IQR. The IQR we haven't calculated yet, so we're going to go ahead and write it in, and that's minus 62. The order of operations here students need to pay attention to. Grouping symbols come first, then we multiply, and then we add last. Let's set up the other calculation, and then we'll calculate. Q1 is 62. Here we will minus, make sure that you remember that portion. And then again, it's 100 minus 62. So I'm going to have students pause the video and calculate that. And so you find that the values are 157 and 5. So now you want to ask yourself if all of the data is contained within this new range of numbers that we found. So is 24 the smallest number in the data? Is that in between these two? Yes. Then we would jump up to the maximum. Is 190 contained within 157 and 5? No, it is not. So we know that 190 is indeed an outlier. So if 190 is an outlier, that could mean that there is some indication about why that might be. Maybe that person is making too much money as it relates to their salary in baseball. So now let's have students go ahead and identify the outliers on this particular set of data. Pause the video and I will go ahead and show those calculations momentarily. Students can also draw the box plot if they feel they need more practice with that, and I'll show that answer as well. So we had calculated the 5-number summary earlier. Make sure when you are displaying the 5-number summary that you go ahead and label everything appropriately. And it is okay to use abbreviations here if that helps you save some time. So here it is in a box plot form. Make sure you include a title. And there's really not much to go on here. I'd probably call it Best Actor Oscars and include the date. As far as the outliers go, these are your calculations. All of the data is between 59.5 and 23, so you would say here that there are no outliers.